Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. You might have noticed in your programming travels through Python land that there are several different ways of importing modules in Python. For example, here I have 4 different versions of a script that generates and prints a random number between 1 and 6 called d6v1 through d6v4.py. Each one imports the randint function in the random module in a different way. And you can see that the function called to randint looks different in all but 2 of the versions. So besides the obvious, in 2 of the programs I don't have to prepend the call to randint with random, and in 1 I get to choose what I prepend with. What are the advantages and disadvantages to these different methods? When should you choose one over another? What is going on behind the scenes? And can you write and import your own modules? We'll tackle these questions one at a time, and if you have additional questions that aren't answered by the end of the video, please put them in the comments and I will do my best to get to them. I'm going to begin by answering what is going on behind the scenes, because it's necessary to understand the answers to most of the other questions. And to understand that, we need to understand a Python namespace. According to the Python documentation page, Python Scopes and Namespaces, a namespace is a mapping from names to objects. I find a definition often isn't enough to understand a concept, though. What does that mean? So first, what is a name? A name is an identifier, like the name of a variable or function. And then what is meant by object? Well, you can think of it as a space in memory that holds data of some kind, a variable value or the code for a function, for example. So the namespace is the way that Python figures out what object you're talking about when you use a name in a program, so it can resolve it to a value. In the example I have here, called namespace example.py, there are 2 functions, rollDie and main, both contained in the one script or module. The rollDie function has a parameter numSides and no local variables. The rollDie namespace, therefore, consists of one mapping, the name numSides, and the object in memory that holds the value passed in. As an example here, I have used the value 6. The main namespace has no parameters, but 2 local variables, die1 and die2. Therefore, the namespace has 2 mappings, and I've given these variables example values of 2 and 5. And finally, the module namespace has 3 names defined for the 2 functions and the imported library. There are also a number of built-in variables that I'm not showing here. I have another video devoted to the topic of scope and namespaces that I'll link here and in the description if you'd like to dig deeper into this important topic. One thing that is very important to understand about namespaces is that they are the set of names that are defined in a particular block of code, such as a script or a function. And the namespace for one block of code is not visible in another block of code unless it encloses that other block of code. So if I tried to reference the variable die1, located in the main namespace, from within rollDie, Python would tell me the name is not defined. Similarly, I can't reference numSides from within main. But I can reference both function names from within the functions because they are defined in the enclosing namespace, which is the module level namespace. Again, see the scope and namespace video for a deeper dive into this concept. The reason that each function and module have their own namespace is to prevent naming collisions. I could have a variable in main called numSides. In fact, let me modify it in that way. I'll write numSides int equals 20, for example. That numSides within main is a separate numSides from the one within rollDie. This way, I can have variables within 2 functions with the same name but different values, and I can give my variables meaningful names without worrying that they'll collide with a variable in another part of the program. So if in one function or script you have a variable called x, and then in another function or script you also have a variable called x, there is no confusion between those 2 variables. If they're in 2 different namespaces, they're completely separate variables. This is necessary for programs of any size at all, because we'd be in big trouble if we had to think up unique and meaningful names for every variable in a large program. We can see the names that are defined in a namespace by using the function locals. I encourage you to download this program and print the result of locals in each function and in the module, but predict the results first to ensure you fully understand namespaces. Now that we've covered namespaces, we can return to our import examples and understand what's going on behind the scenes with the different import methods. Let's print the result of the locals call in each program. I'll import pprint and prettyprint the results of that call for each example. Pprint will just print the locals dictionary a little more neatly, with one name value pair per line, than a regular call to print. I have a video about dictionaries if you're unfamiliar with this incredibly useful data type. I'll link it here and in the description. We'll begin with d6 v1.py, which has import random at the top, and then prepends the call to randint with random. When I run it, we see a lot of behind-the-scenes variables, such as name. Remember from if name equals main fame, but when we move beyond the variables named with the double underscores, which some people call dunder variables, double underscore variables, we see pprint and random. 2 additional names, one for each import, and we can see when we look at the value that the objects these names reference are modules. So the module name has been imported, meaning we can use the module name and Python will be able to find the object we're talking about, which happens to be a module. If we want to access a function in the module, such as randint, we need to prepend it with the name Python will recognize, random, and then it will be able to find the function. Now let's look at d6v2.py, which has from random import randint at the top, and does not prepend randint with random. I'll add the pretty printing code and let's run it. And again, after the dunder variables, we see 2 additional names, one for each import, pprint, and randint. And randint isn't a module, it's a method. A method is an object-oriented name for a function, basically. So within this program, the name of the randint function or method itself is what's visible. So that's the name we use. We've imported one function name from the module. Now let's look at d6v3.py, which has from random import asterisk at the top and does not prepend randint with random. The asterisk or star is a wildcard. That means go through random, find everything, and import it. I'll add pretty printing code and let's run this. Whoa. I don't even want to count all of the names that were imported after the dunder variables. There are a lot. So you can see that importing everything from the library, while it did allow us to use randint without prepending with the name random, really cluttered the namespace. The more names in the namespace, the more opportunity for a collision, especially if we're going to import additional libraries. Many libraries have functions or methods with the same name. Let's look at our final example, d6_v4.py. This one has import random as r at the top, and then instead of prepending randint with random, we prepend it with r. I'll add pretty printing code and let's run this. Okay, and we're back to just 2 names defined beyond the dunder variables, and one of them is r, which references the module random. So here, the name r is defined as a name that means the random module, so we use that name, and Python knows to go look in the random module, because that's what it references. Now let's talk about the relative advantages and disadvantages of each method. The advantages to importing the entire module are, first, you'll have access to every method and constant and class in the module. And second, you'll add only one name to the namespace. While it's common for modules to have methods with the same name, it's uncommon for modules to have the same name. Another advantage is that it's very clear when you're accessing a part of the module, like the randint function, where that function has come from. Imagine a long program and you're reading the code and you come across random.randint. Even though you might not be familiar with all the code in the program you're reading, you'll know randint is in the random module. You won't wonder if it's part of the program you're reading. So I frankly think this is a winner for readability. The advantage to importing just the one function or method you're going to use is, again, you'll add only one name to the namespace. At the top of the program, you're making it very clear what function you're going to be using from that module. And you only have to type the function name when you use it. You don't have to type the module name as well. The only disadvantage might be readability. Imagine again that long program that you're reading and you come across the randint function. If you're not familiar with it, you might think it's part of the program. You might not realize it's been imported from another module. Quite often, when we're debugging, we jump into various modules somewhere in the middle. So it's not so unusual to be dropped into a block of code you've never seen. Making that code as readable as possible is very important. Now, let's talk about importing the wildcard from a module. The advantage is, yes, you now have access to every function in that module. Everything, in fact, not just functions. And you can refer to each function by its name without prepending with the module name. The obvious disadvantage is the clutter you've added to the namespace. Unless you're going to use every single thing in the module, you shouldn't be adding it to the namespace because of the potential for collisions. And my comments about readability when you do not prepend with the module name apply here as well. Finally, we have the example in which we've given the module a new name. The advantage to this is that you can choose the name you want for the module, and if there are long combined module function names, you can make them shorter. And of course, you're only importing one name into the namespace, which is good. But the disadvantage is that you might be making your code less readable if other programmers aren't familiar with the name you've given the module. How would they know that R refers to the random library unless they went hunting for your imports? My advice here is to use this method when it's the common way to use a library. For example, the NumPy library is usually imported as NP. If you use NumPy, you should import it as NP because that is what other programmers will expect. The last question I proposed was, can you write and import your own modules? And the answer is absolutely. Any script you write is a module and can be imported into another script by using the name of the file without the .py. I'll demonstrate by going back to namespace example.py. I'll create a new script called rollingdice.py. At the top, I will import namespace example by writing import namespace example. The name of the file, but without the .py extension. And now that I've imported the module, I can invoke either of the functions that are in the module. I'll invoke rollDie by writing print namespace example.rollDie10. And I'll run the program. And it prints 5. And remember the function of if name equals main at the bottom of namespace example? When I run namespace example, the string main is in the name variable, and the script begins executing at main. But if I'm importing the script as a module, its name is not main, and it will not begin executing. I can therefore use anything from the module, but it won't run as a program. Normally, when you create a module, it will have a purpose, such as writing a set of functions that are going to be used by one or more programs you're writing. Maybe you find that you're using the same functions repeatedly, and so it makes sense to place them in a module that you can import into your script. Note that these two files are in the same directory. But you know that you can use modules that are part of the Python installation, such as random, or that you've installed as a third-party library, such as pygame. So where does Python look for modules? Python will follow the module search path, which begins with the built-in modules, and then searches in other directories, including the directory with the currently executing script and the site packages folder. You can see the module search path by importing sys and then printing the sys.path variable. I will include a link to the module search path documentation in the description of this video. So I've covered the topics I set out to cover, but again, if you have follow-up questions, please write a comment on this video. Each of these topics that I touched on, imports, namespaces, and writing modules and packages, has a lot of depth that I haven't covered here. I hope you found this overview useful and that you play around some with the ideas. That's the best way to learn. As always, have fun and keep coding.